Brilliant. So this session is actually the last one that we've scheduled like this, and it's on home energy use and transport. That doesn't mean we're not doing anything else after this. We are sort of shifting the focus, if you like, onto ways to engage with people, campaign actions, and hopefully sort of supporting each other in making changes in our own lifestyle as well. But we've got a big focus on the COP26 UN conference and ways to engage with MPs in the run-up to that. And there's a relay event as well that is going up the country from the location of the G7 summit. So it started last week, zigzagging up the country, going to Glasgow in time for COP26. And that's passing through Leeds in mid-September. So we're planning some events around that when it passes through Leeds. So get in touch if you're interested in being involved in that. And there are lots of different ways to get involved. It doesn't all involve walking long distances. So yeah, do get in touch if you want to hear more about that. But I'll move on to the topic that we are focused on for this evening. If I just share screen. It's going to be a lot of me talking, but we will have some interaction, sort of Q&A at a couple of points as well. Great. Can someone wave and tell me if that's visible to everyone? Brilliant. Thank you very much. Okay. Why is that not proceeding? Right, here we go. Oh yeah, if you wouldn't mind muting yourselves. Make the recording a bit cleaner. Great. Okay. So the UK, this pie chart shows the average UK carbon footprint for an individual broken down into different categories. I showed this pie chart a couple of times, but mostly talked about it in the first session we ran at the back end of last year. Each of our carbon footprints will be a bit different, but I think it's helpful just to look at this average breakdown. And in the first session, I talked through each section of the pie chart and briefly described some of the ways that we can reduce our emissions in each of these areas of our lives. This time, I'm going to focus on energy and transport, which, as you can see, between them make up around half of our personal carbon emissions. I produced this pie chart based on a very helpful book, which I should give credit to, called Carbon Detox by George Marshall. And again, we've mentioned this a couple of times in these sessions. One of the things that this book does is to give a very helpful method for calculating our carbon footprint. And Izzy and I used this to calculate our carbon footprint several years ago now. And then a year or two later, I thought it would be helpful to update the calculation to see if we could see the impact of some of the things that we'd done, like insulating our house and switching to a green electricity supplier. And overall, our emissions had gone down, but the section for goods and services had gone up. And we realized that the reason for this was that in the time since the first calculation and the second one, that we'd both had a pay rise. And if you were with us for the goods and services session, you might recall how we talked about how there's a carbon footprint associated even with money that we have in the bank, because even if we're not spending it, the bank will be investing it for us, and they might choose to invest it in something that increases emissions or something that reduces emissions. And not all banks are the same in this regard. But the key point I wanted to make around this now is that those of us with less money will almost inherently have a lower carbon footprint than those with more money. The purchasing and investment decisions made by someone who's wealthy can reduce or perhaps reverse that if care is taken. But I don't want to get too distracted from the topics of energy and transport by talking about money. But the point I wanted to make at the start is that I wanted to make that point at the start because a lot of the things I'm going to talk about this evening cost money and won't be within everyone's reach, at least for the moment. Of course, prices aren't static. New technologies tend to get cheaper as businesses get smarter in the ways that they make them, and they're motivated to do this when there is a demand for those products. A really great example of this is the cost of solar panels. This graph compares the cost of solar photovoltaic panels, which is the type that generates electricity rather than hot water. And as the price fell, demand increased. And demand increased because manufacturers worked out ways to make the panels more efficiently and cheaply. And you can say that sentence either way around. The price fell, so demand increased, or the price fell because demand increased. Both are correct. So at the start of the graph, you can see that panels were mainly used in the space sector on satellites and the like. And by the end of it, they're a regular sight on roofs, and they're in calculators, and even my watch is solar powered. They're everywhere. They're much more ubiquitous than they were at the start. The International Energy Agency stated last year that solar PV is now the cheapest source of electricity in history, and it's the cheapest source of electricity in most countries, cheaper than any other source. In those countries where it's not the cheapest, wind power is often the cheapest option. So the point I'm making is that the world is going through a big energy and carbon transition. And this means that new technologies and new ways of doing things, some small changes will have a big impact. But to make the scale of changes we need to make to reduce our carbon emissions, we'll also need to make some big changes. And that these big changes often cost a lot initially, but those with money to make those changes will increase the demand for the new technology, and the price will then fall, so that those with less money can then afford it. And whether we're richer or poorer, we have different roles to play in this process, making the change at different times. So this evening, I'm going to talk about some things that are cheap or even free to do, but I'll also talk about some things that are quite expensive. And the reason I'm doing this is because these are new or rapidly developing technologies, and I want to demystify them a bit and to point ahead to what is hopefully going to become much more mainstream in the next few years, I should say. Minutes, that would be brilliant, but okay. So this pie chart, again, I have shown before, it shows the average breakdown of energy demand in a typical UK home. But the breakdown of energy demand in your house and my house will be different. Every house is different, and there are many reasons for this. So houses will be different ages and different sizes. They will have different numbers of people living in the houses, and each person will have a different lifestyle, and the lifestyle of each person will change over time. The appliances that we put in the houses, again, will be different ages and efficiencies in different conditions, and there might be a different number of TVs or computers in a house, for example. And then the systems for heating and hot water will use different fuels. Some will be gas, some will be electric, some will use oil or LPG, different ages or efficiencies again, different condition or level of maintenance, and then again, controlled in a different way. So if we compare even two identical houses and kit them out with the same appliances, their energy use will be different because the occupants will behave differently. To save energy and carbon at home, we can consider the house, the appliances, and the way we use them. Having said all of that, in most UK homes, heating is likely to be the biggest energy use. So this is an important area to focus on, and it's something I'm going to spend quite a lot of time talking about this evening. The next three slides will be familiar, as I used these back in October, but most of this presentation isn't recycled, so please don't tune out if you've seen this bit before, but I thought it would be helpful just to go over them quickly as a bit of revision. This slide shows a few things that we can do for free. So dealing with the largest home energy use, turning down the heating by 1 degree typically saves around 10% off our heating bills. And if we can take other steps to keep warm, then it can make a big difference. So blankets, warm clothes, etc. Seems a bit perverse to be talking about this today, but anyway. Washing clothes at a cooler temperature can also make a big difference. Drying clothes outside rather than using a tumble dryer or on a clothes horse. Taking a shower instead of a bath. And then in the kitchen, one big thing that we can do is to keep lids on pans when we're cooking as much as possible. Boiling a pan of water with the lid off on full heat uses roughly twice as much energy as boiling it gently with the lid on. And in both cases, the water's still at 100 degrees and the food will cook at the same speed. This slide is for low cost measures, typically costing from a few pounds up to a few £100. In the kitchen, fridges and freezers are on all of the time, so it's well worth checking that the model we have is efficient and replacing it if it's not. Microwaving food is the most energy efficient way of cooking. It obviously only works for certain things. Izzy and I use a microwave steamer like the one pictured here, which we use to cook rice and vegetables. It's very easy to use and the rice never sticks. LED lighting technology is improving rapidly and is available for almost every fitting type now. And a new LED bulb can use around half the energy of even the older low energy bulbs. Because it's progressing, the technology is progressing so rapidly, what I would suggest is don't buy the replacement until the bulb is gone, because if you stockpile them, you'll probably find that what you've stockpiled isn't actually the best technology when you actually come to use it, and probably more expensive as well. A simple thing to do is to switch to a renewable electricity tariff, but there is a pitfall here. So there's a Which article, which I've put the link to there, but essentially the pitfall is that a lot of the green tariffs that get marketed are essentially based on the company buying renewable energy certificates from other companies that have generated that electricity for them. And it's debatable whether switching to one of those tariffs is actually making a big difference. It's explained in a lot more detail in that Which article. It's a very readable article, but it's a very helpful one if you want to explore it. But the basic conclusion that that article came to is that two electricity companies pictured there are the ones that they could guarantee were making a big difference through customers, the money that customers give them going directly into investing in new renewable technologies. There are possibly some others now. The article was written in 2019, and for some companies, it was more a case of they couldn't get enough data to conclude one way or the other, but those two they were sure about. There are also some relatively low-cost ways to insulate our homes. For example, topping up loft insulation or fitting cavity wall insulation. I'm going to talk about those things a little bit more in a few minutes' time. Finally, the higher cost measures, and these will typically cost a few £1,000s. The man in blue here is actually my dad, and we were fitting internal wall insulation, and there'll be a lot more discussion about that in a few slides' time. And it's made a huge difference. We fitted that in our whole house, and last winter we didn't need the heating on at all until early November. There's also external wall insulation, which you may have seen being fitted. Several houses around Leeds I've seen having this installed. And then we could consider renewable energy technologies. And again, I'm going to talk about those in a few slides' time as well. It's worth saying at this point that I've written a blog which details how we fitted internal wall insulation in our house. So there's a link to it there, which I can put in the chat at the end of the discussion as well. If you're in a position where you're renting a house, as a tenant, you have certain rights as well. You can ask your landlord to upgrade the property to improve its energy efficiency. And it's helpful in having that discussion to point out that it would also increase the value of the property. When you're first renting out a house, it needs to meet a certain minimum energy efficiency standard. And if you're in a position where you're renegotiating a rental agreement or moving to a new house, I can help explain what that means to you and what your rights are. There are a lot of different graphic versions of this graphic online. It's really talking about where the heat is going from our houses when we need to have the heating on. The exact numbers or percentages will vary depending on the age and insulation. Sorry about that. Phone's ringing. The exact, so depending on the insulation in the house, the age of the house, whether it's a flat or a terrace or semi-detached with different surface area, larger houses will need more heat than those that butt up against other homes, which will lose less heat. So draft sealing is often a simple, cheap and effective task. There are lots of different products that can help with most types of drafts that you're likely to find. It can feel a bit like being an energy detective, looking very closely at every corner of the house to find where cold air might be getting in. I don't know if that's coming through, sorry about that. It will stop in a minute. Most solutions on this slide will cost less than £10 and take less than an hour to do. Having said that, my favorite picture here is of this draft excluder at the bottom, which is a very neat solution. It slides along as the door opens and closes. I guess a skilled person could probably produce one in less than an hour, but I think most people would take significantly longer than that. But it would be a very satisfying thing to make. The foam tubes on either side could be pipe insulation, which costs about £1 a metre. One word of caution here is that it's important to have ventilation. The difference between a draft and ventilation is simply that ventilation is deliberate and controlled, whilst a draft is neither of these. Poor ventilation can cause damp and mould, and if there's combustion happening in the room, such as an open fire, then we need fresh air to feed that flame. If we don't do this, then we can cause carbon monoxide, which can be fatal. So if you're not sure, please do take advice before sealing things up. In terms of controlling damp, something I've found very helpful is to have a humidity monitor like this. It costs about £10 to £20, and I use it to just check what the humidity is in a room, and I try and keep the humidity below about 70%. It's not always possible depending on the weather outside, but it gives me an idea of when it's helpful to open the windows, which I do even in winter sometimes, to help get the humidity down. And then I can use this and I know when to close them again because it tells me when I've got the humidity down to a level that is more suitable. There are some less obvious places where drafts might be found. In a few slides' time, I'm going to talk about how we insulated the walls of our house. But as part of this process, I removed the wooden architrave around the inside of our spare room window. And this revealed many large gaps around the edge of the UPVC window frame and the brickwork. The window had been fitted professionally just a couple of years before, and they'd used the standard method of silicon sealant to seal the frame to the bricks. But there were several gaps, some of which I could easily push my finger or a large screwdriver through. An 80p tube of silicon sealant solved the problem. If I'd thought to look before I'd removed the timber, I could even have done this job from outside. Please do be careful if you're leaning out of a first floor window. The ground floor is obviously much easier. If you're thinking of replacing an extractor fan, then you might like to consider one which recovers some heat from the room. So it recovers heat from the air that's leaving the room and uses it to warm up air from outside that's coming back in to replace it. There are lots of these on the market, and they do cost a bit more than a normal extractor fan, but they're not a ridiculous amount. So types of insulation. There are two key types of insulation that I wanted to quickly explain before I talk about the different ways that they can be used. There's mineral fiber, or man-made mineral fiber, which is what the acronym stands for there, and PUR, or polyurethane foam. Each of these have different names that you might hear. Mineral fiber is often referred to as just loft insulation or rock wool, which is a brand name, or fiberglass. And it's a fluffy material bought in rolls that can be rolled out in lofts or pushed into other spaces. PUR is short for polyurethane, and it's a stiff slab or board, which is a bit like polystyrene packaging that you might get around a new TV, for example. It doesn't bend or flex really at all, so it needs to be cut to fit the space it's being put into almost exactly. There are a few variations on this product. PIR is another name of something almost exactly the same. And then there's a famous brand name, Kingspan, but there are plenty of other companies that make similar products. Both types give off dust when being cut, so it's well worth wearing a face mask and eye protection. And long sleeves, particularly if you're using mineral fiber, because it can make you itchy. Although I personally haven't found that to be a big problem, it can really be a big problem for some people. Mineral fiber cannot burn, whilst PUR can, although it is resistant to fire to some extent. PUR costs more, but it's also more insulating. So you can use a thinner layer of it to get the same effect, which is what this graphic in the middle is talking about. Approximately half the thickness, which can be really helpful. So the net effect of being more expensive but more insulating is still that mineral fiber is a bit cheaper, but not by a big margin. They're different products and they're best used in different places. So I'm going to explain a bit about that in a few slides. So when I say insulation, the first thing that probably comes to mind for most people is insulating loft spaces, and it's been a standard home improvement measure for decades. All that really changes over that time is the recommended thickness of insulation that we should have. The current advice is that it should be around 40 centimeters or 16 inches. This is deeper than the space between most joists in most houses, joists being the timbers that run across the floor of the loft. So we're effectively saying that we need two layers, one between the joists and another rolled across the top. As many people use the loft for storage, then this can present a challenge, but there is a fairly simple, although perhaps not quick, solution to create space for this extra depth by supporting the timber loft boards on something. This image shows a product, this image here shows a product that my brother-in-law has used in 2 houses now. It's called Loft Legs, but you can see there's a few other products that essentially do the same thing. It's a bit time consuming, but it's not, I think it only took him a few days to do that. Another source of heat loss that is often overlooked is loft hatches. It's quite normal to spend perhaps a couple of £100 on insulating the loft, and then to leave the loft hatch as simply a thin sheet of wood or sometimes plastic. A small but thick foam insulation slab costs just a few pounds and can be glued onto the back of the top side of the board, and draft seals can be fitted around the edge of it. And if it's not closing tightly, then you might like to put some clips like these to hold it in place. Several years ago now, I played a very small role in producing a guidance manual, which is free to download, and it explains how to insulate older homes, the type with solid walls. You can download it from the links below. Some of the images on the next few slides are taken from this. So one of the principles that the manual explains is that insulation should be continuous. It should wrap around the whole of the building, like the red line shown in this image. And there are lots of spaces that often get overlooked when insulating a house, such as the space where the wall, the strip of wall that is between the floor of one room and the ceiling of the room below, or the roof of a bay window, or the floor of a bay window. I mentioned cavity wall insulation earlier. Houses built after around 1930 generally have cavity walls, but it wasn't a standard to put insulation in the cavities until around the 1980s. And even then it was quite thin insulation. The building regulations have tightened up over the last few decades to help save more energy. You should be able to tell which type of wall you have by looking at the brick pattern if it's a brick house. If you can see the ends of bricks, then the wall is probably solid, but you can also measure the thickness. A cavity wall will generally be about 30 centimeters or a foot thick, while solid walls are thinner, more like 20, perhaps 22 centimeters thick. The house that Izzy and I live in has solid walls. So to insulate our walls, we had a choice between internal and external wall insulation. They're both very similar in that the process is to attach slabs of insulation to the walls and then to fix a new decorative layer over the top. External wall insulation generally requires a professional, and personally I've found these quite hard to find. And we opted for internal wall insulation because we could do it ourselves with some skilled advice. And this made the job a lot cheaper, although it is still a big job to do. If you're interested in doing this, please do ask me more about it. I'm happy to talk for quite a long time. I don't have time to explain the whole process today, but there are several non-obvious things that need to be done right. They're not necessarily difficult, it's just they're not obvious. In essence, the process is to attach slabs of PUR type insulation to the walls using both expanding foam adhesive and mechanical anchors, and then to glue plasterboard over the top of this. And we've done this in almost the whole house now, and it made a huge difference in terms of comfort and heating. And at this time of year, it's worth adding that it also helps to keep the heat out as well. People always ask if it's a problem that the room gets smaller. And the honest answer is that it's really hard to tell that there's any difference at all. Unless there's a piece of furniture that is already fitting very tightly into a space, it's just not noticeable. And it's odd because we have a huge stack of insulation delivered and it seemed to fill the lounge in the middle of the floor. But once we'd fitted it, it was just like it had disappeared completely. So back to something quicker and cheaper. Some of the heat given off by a radiator is directed into the wall that it's attached to. If the radiator is on an inside wall, then this means that the wall absorbs some of that heat and the room warms up more slowly, which isn't ideal. This is a bigger problem when the radiator is on an outside wall because the heat is not only delayed, it's actually leaving the house completely. To help reduce this, we can fit a reflective foil behind radiators. There are a few different types of foil that can be used, and they're all pretty similar in their performance. The type that I've found to be cheapest and easiest to fit is essentially a type of bubble wrap with foil on both sides of it. The bubble wrap layer also acts as a thin layer of insulation. The link here gives some instructions on how to fit this insulation. Essentially, you first measure and cut the foil so it's 50 millimeters or 2 inches smaller than the radiator in all directions, and cut some slots for the brackets. Then paste PVA glue onto the back of the foil, and to stop smearing the wall with just find the right picture. Yeah, to stop smearing the wall with glue when we're sliding the foil back down the back, use masking tape or something to hold a sheet of paper or something similar to the wall above the radiator, and then use something long to push it to the wall. You may find balls of scrunched up paper helpful to hold it in place whilst the glue dries. This only costs about £3 a radiator, and once you're in the groove of doing it, you can get through several in an hour. Another area that we can insulate is under the floor. This is a big surface area and it's often overlooked. The job can be fairly straightforward, or very difficult, depending on how easy it is to access the void under the floor. Needless to say, if you have a solid floor, then a different approach is needed. These photos show 3 different methods that I'm aware of. The first 2 are solutions that require professionals, and as far as I know, neither of these is available in Leeds at the moment. There's a company called Qbot, which has developed a system with a remote controlled car which sprays insulation onto the underside of the floor. At the moment, they seem to only be operating in London, but I guess if they get a lot of inquiries in Leeds, I'd like to think that they'd expand their business. This second image is of a Dutch system called CompoFloor, which is currently going through an approval process for the UK regulations. But apparently a team can cut out a timber floor and replace it with insulated panels in 2 days. The occupants need to clear the furniture and arrange for the carpets and furniture to be put back. But apparently it seems a very quick process. There's some great videos on their website as well. The final 2 photos here show a method which I've done myself and helped a couple of other people to do in their houses. Some of you may recognize the people in both of those photos. Essentially, the process is to seal all the gaps with silicone and expanding foam between the floorboards, and to attach layers of loft insulation or mineral wool to the underside of the floor, holding it in place with wire or bits of timber. As ever, I can explain more detail on this if it's something that you'd like to consider. In our house, this process was very simple because we have a cellar that we can stand up in. We helped Tim and Grace, who some of you will know, and this is Grace, in case you were guessing. And the second one is me. Izzy's whispering in my ear, saying, "Who's the second one?" It's your husband, dear. Don't worry. You were there. It's harder. It was much harder to access their floor voids. The access hatch was tiny, and in some areas the height was very restrictive, more restrictive than it looks in that picture. So if anyone knows a team of environmentally passionate potholers, please do let me know. So getting back into the mindset of being an energy detective, there are probably all sorts of little corners of the house where we can easily stuff some insulation. These photos are some places where we've done that in our house. Insulating under the bath, particularly where it butts up against an outside wall. Under the kitchen cabinets by removing the kickboard, insulates the floor and also, again, a bit of the outside wall. This photo shows the underside of the stairs where they are above an unheated basement space. And again, you can actually see some netting there holding the insulation in place. I put a sheet of timber over the top of that after that photo was taken. And then this is the loft space above our bay window. And I also helped a friend to insulate the space under their bay window by sticking a sheet of PUR insulation to it. The cost figures here are for the materials only. The bath and the kitchen literally only took a few minutes, whilst the other jobs took a few hours. The loft above our bay window was probably the longest job. Access was quite difficult and it took most of a day, but that did include a trip to the hospital because I got grit in my eye. Not too badly, unfortunately though. I've insulated 2 doors in our house. The first one I did is a standard wooden door which leads down into the cellar I mentioned a moment ago. The cellar isn't heated. I built a wooden frame around the edges of the door and filled it with a 5-centimeter slab of PUR insulation, all firmly glued into place. And then I stuck a sheet of wood over the top and painted it white. A key thing here is obviously to make sure that the door still opens and closes properly. The materials for this job cost about £50. A more challenging job, there's a couple of photos there. So a more challenging job was to insulate our front door. This is original to the house. in our case, which was 1905, we think. So we wanted to keep the door. A simpler solution would have been to get a new door, making sure that we chose one that was well insulated and well draft sealed. In essence, the method I used for our door was the same as for the basement door, but given the aesthetics, the insulation was just 2 centimeters thick, which is still well worth doing. As the timber frame went round all the windows and the letterbox, and I made, click onto the next picture. I made wooden surrounds for all the locks. A key thing here is making sure that the key is still long enough to reach the mechanism, which is another reason to keep it just 2 centimeters thick. I fitted an insulated flap over the letterbox, and again, I filled the wooden frame with insulation. The windows were single glazed stained glass. So to insulate these, I had some double glazed units made to measure for each of the windows, which isn't as expensive as you'd imagine. And I fitted these within the depth of the insulation, which you can see here. This is before it was fitted, but that's where the glazed unit sat. Once the timber sheet was glued into place and the insulation painted over, the door looks pretty much, and those are the glazed units. So this is before and this is after. The door looks pretty much the same. And the material cost for this was about £180, but most of that cost, I think about £140 worth, was for the new glass. And that includes actually the fan light as well up here, which we put a triple glazed unit in because there was a bit more depth. Speaking of glass, when we decided to replace the large bay window in our living room, because it takes up so much of the wall, we decided that we wanted to go for a triple glazed window. And we found that several of the companies we approached seemed to be very reluctant to sell us triple glazing. Some of the responses were wildly inaccurate, and in one case, quite rude. And after a while, I realized that this was partly because window companies buy in the glazed units and specialize in making and installing the frames. So asking for any of them to use a type of glass that was outside the 2 or 3 standard glass products that they buy in, was a really big hassle for them. So I approached a glass company, rather than a window company, and they manufacture the glazed units and buy in and fit the frames. So they were very happy to make any type of glass I wanted. And yeah, we got what we wanted eventually. Another option, if you've got UPVC frames particularly, and if there's nothing wrong with them, then a cheaper solution is to just replace the glazed units. This is a standard job and is often done when the seal has failed and the glass has misted up, but it could also be done to reduce the heating demand of the house. The beading around the edge of the glass can be prized off with a thin blade and the glazing swapped out. And it's something that a competent DIY person could do themselves with a bit of guidance as well. But there are plenty of companies that will do that for you. Just briefly on hot water and pipes. Pipe insulation is very cheap. It's about £1 a metre. There are different thicknesses available and it's not a lot more to buy the extra thicknesses. What I would say is when you come to fit it, if you find that the pipe is hard up against a wall, you might think, well, I've bought the extra thickness, but I can't physically get it round the pipe because of where the pipe is. So it's worth thinking ahead. The insulation itself is really easy to cut with a serrated kitchen knife or a junior hacksaw or anything like that. And then tank insulation, if you have a hot water tank, not everyone does, even if it's already insulated, a new jacket costing £10 to £15 can be wrapped around it to insulate it even more. Again, if you've got space around the tank to fit it. Just because I've talked through a few things that you might be tempted to do yourself, I just thought I should put in a few safety points. Don't do anything if you're not comfortable with it. And if you are uncomfortable, please ask for help. There's plenty of people around who know how to do this sort of stuff. Don't insulate around electrical cables. There is a solution if you need to fit insulation near electrical cables, and I'm happy to talk you through that, but the cables could overheat if they've got too much insulation around them. There are some ways to insulate houses that can cause damp problems. And again, if you're not sure, I'm happy to explain where the risks are around that. It's always worth using the right protective equipment. You don't necessarily need as much as this guy is wearing in that photo. It depends what the job is. If you're using expanding foam, be very careful. It sticks to absolutely everything, apart from polythene, but it will stick to almost everything else, and it's a bit of a menace, and it keeps expanding for ages. Insulation dust from cutting it is really light, so it tends to float around a lot and is therefore a lot easier to inhale or get in your eyes. So it's well worth cutting outside and just keeping your head upwind of it where you're cutting. And again, really expanding foam particularly, but other things give off fumes, so it's well worth ventilating the space properly when doing any of those things. In one of the previous talks, I explained that the UK electricity demand is now getting lower and lower carbon. Over the last decade, there's been a really big shift away from fossil fuels. Coal has almost completely disappeared from our energy mix. Wind and solar are increasing. And last year, the government announced, this was in Boris's 10-point plan that you might remember, the aim to triple wind generation by 2030, which is really ambitious. We're now getting less than half of our electricity from fossil fuels, which means that the emissions from the electricity, the carbon emissions from the electricity that we use have approximately halved in the last 5 years. One of the effects of this is that it's now lower carbon to use electricity than gas. So Izzy and I have changed our gas cooker for an electric one. This decarbonisation of electricity has gone really well and is a key part of government policy to making all of our buildings zero carbon. So remember this pie chart from earlier on. If we turn that into a graph like this, we can show the effect of the electricity getting greener. So I've lost my place in my notes. Where are we going? So even if we use the same amount of energy for lighting and heating and all the other things that we do, our carbon emissions will go down because of changes being made to our electricity system. The first bar here is showing roughly where we are today, but the last bar is showing where we get to when our electricity gets to zero carbon. If we're still using gas for heating, hot water, and cooking, then we will still have a significant carbon footprint because the gas is a fossil fuel. So one of the ways to deal with this is to switch everything over to electricity. There are a few different types of electric cooker and electric heating. This graph is based on a type of heating called a heat pump, which I'll explain on the next slide. So the first column on each of these two graphs is the same, but on the second column of the second graph, I've shown the impact of switching to a heat pump and electric cooking. And then the other columns here show the ongoing reductions as the electricity we use gets greener and greener to zero carbon. And so as the electricity goes down to zero carbon, then the house becomes zero carbon inherently if it's only using electricity. So something we're going to see a lot more of is heat pumps. There are a few different types of these, but they all work in the similar way. Firstly, I'll just remind us how a gas or oil or LPG boiler works. We take in the fuel and then it's burnt. A small amount of the heat from the burning goes up the chimney or the flue as warm gases, but most of it, perhaps 90%, gets used to heat water, and we use that for heating or for washing. I've shown the simple maths of this here. 1 unit of fuel goes in, about 0.1 unit escapes, and we end up with 0.9 units of useful heat, or 90% efficiency. Heat pumps use the same principles as a fridge, but running in reverse. So heat pumps run on electricity, but rather than letting heat escape into the outside air, they actually absorb heat from the outside air instead. They can typically absorb a lot of heat from the outside air, so we end up with perhaps 3 times the amount of heat compared to the electricity that we put in. It sounds a bit like magic, but as an engineer, I promise it's not. I can explain how it works if you're interested, but it will probably take a bit longer than I've got this evening. Combined with a low carbon electricity grid, this becomes a really effective way to decarbonize the heat in buildings. But they do currently cost a lot, and there are lots of pitfalls in how to install and operate them. So we need training for designers, for installers, and for homeowners who operate the systems. And we also need the manufacturers to work out ways to bring the costs down. And this will happen as demand increases, which is what I was talking about right at the start. One of the really helpful things about heat pumps is that they overcome one of the potential problems with the cost of energy. Electricity costs around 3 or 4 times as much as gas. But you can see that because of the clever way a heat pump works, the cost of heating a home this way will be pretty similar to the cost of a gas boiler, because you're getting 3 units of heat for every 1 unit of electricity that you put in. So we could use a simple electric heater, like a fan heater or the sort that you plug in. That would be much cheaper to buy, but a lot more expensive to run. If the house is very well insulated, then you might decide that actually the cost is so small it doesn't much matter, and it's easier to, or cheaper to go for the low upfront cost. The upfront cost of a heat pump is generally going to start at the moment at around £12,000, which is a huge amount. But there is a government subsidy called the Renewable Heat Incentive, or RHI, which essentially gives about this amount of money back, or a bit more, over a 7-year period. This subsidy is going to close in its current form at the end of March next year. I expect it will be replaced with something, but the details of that haven't been announced. And I expect the subsidy will be lower, and I suspect the price of the technology might come down in response to that, but it's hard to tell. If you're interested in this, I'm happy again to talk through that technology in a bit more detail. So that's the end of the home energy section. How are we doing for time? Pretty good. We could take questions perhaps for 10 minutes or so, if there are any questions or suggestions. There might be ideas that other people have done. I'll stop sharing just for a moment, actually.
Just I saw an article some months ago now about microwave boilers. I wonder if you know anything about those and whether they're likely to be available.
That slightly surprises me, because I should say, many of you know, I work in the field of energy efficiency in buildings. I've never heard of them.
Well, I think it was just using microwave technology to replace a gas combi boiler. Yeah. So the advantage, I suppose, is that there would be very little change to your central heating system and everything else. And the disadvantage, of course, would be that you wouldn't get the multiplying effect of a heat pump.
Yeah. So, I would imagine, I find it hard to see. So when I was talking about heat pumps, I talked about a gas boiler. A good one would be 90% efficient. An electric radiator type thing that you plug in is 100% efficient, because there's no fumes escaping. And a heat pump is roughly 300% efficient. I can't really see how a microwave boiler, and I can see how it could work, I can't see how it would exceed 100% efficiency. So whilst it sounds nifty, it's going to cost 3 or 4 times as much to run. I think.
I think that's probably the case. Yeah.
I'd love to read the article if you've got it.
I can probably find it. I mean, the advantage, of course, if you're well insulated, so that heating isn't a big problem. But then I suppose you could equally use a heat pump.
Yeah, there's a sort of payoff, isn't there, between the choice between the two. If the house is really well insulated and your heating bill is only a couple of £100 a year, say, then you might say, well, actually, it's going to be so long before a heat pump pays back, I'm not going to bother. And that decision process is often gone through for new build houses, particularly. I would say in an older house, it's going to be difficult to achieve that level of insulation, but it could be done. I can see the Weises have a question.
I was just going to add to that, isn't one of the problems with a heat pump that you can't get the instant heating effect that you get from gas, and so therefore for hot water you have to move to having a hot water tank, which many houses no longer have, and for central heating you've got a long heat up time. So I think the microwave thing was potentially a solution to that, which gives much more, not quite as instant as gas, but much more instant than heat pump.
Yeah, that's right.
It is correct. So for hot water, it uses a tank and it heats that tank up. And I mean, many houses, older houses, will have had a tank historically. It may have been taken out and the space might have been used. But yeah, if the house has only ever had a combi boiler, finding a space for the tank could be a challenge. In terms of heating, it's when I talked about sort of training, if you like, for householders, there is a sort of change of mindset in how the heating is used, and it is better to have the heating on for a slightly longer period. And if you're in and out of the house a lot, timing it so it turns on a bit longer before you return to the house. So it's a change of mindset of how it's used. But I would say if the house is insulated, it's not going to cool down as much either between periods when the heating is on. So that warm-up time becomes less relevant. Amanda.
When I looked into heat pumps, Ewan, it seemed to say that they were less good in the winter because it's colder outside. And therefore, the time when you most need the heat, you can't get so much.
Yeah, so when the heat pump when the source, you're absolutely right. When the source for the heat pump, the outside air is colder, they work a bit less efficiently, and the capacity, the amount of kilowatts that they can output drops off. But the system should be designed taking that into account, because it's not a surprise that that's when you need the heating. So if it's designed properly, it should be okay. And I mentioned actually there are other types of heat pump as well. So there's I described an air source heat pump, but you can have ground source heat pumps.
I looked at them.
Yeah, they cost even more. But essentially you put coils of pipework under the ground, and you can either dig a big trench and lay them in, or drill vertically down to quite a depth and put loops of pipe into the ground. And that overcomes that problem in that the ground is a more stable temperature, about 10 degrees all year round. But yeah, I know from projects I work on with work that as soon as you're doing anything underground, you're not sure what you're going to hit, you're not sure where everything is, and it just puts the cost and the risk up. So personally, I would say air source. But yeah, you are right. If the system's designed properly, and this is a big learning curve. To put it in perspective, though, a heat pump is the standard heating solution for most of Scandinavia, and it's colder there than it is here a lot of the time. I would say most of Scandinavia outside of the cities. In cities, they'll use district heat networks. But yeah, it's about designing the systems to suit the house. It's also true to say in Scandinavia, people's houses are generally really well insulated. Yeah. Any other questions or comments or tips from experience? Janet?
Yeah. This might be a bit of an obvious question, but some people might think the answer is obvious. When you do the interior insulation, just do it on the outside facing walls?
So primarily, yes. What we did, so if you imagine you've got a house, let's say it's brick, the partition walls between rooms might often be brick as well. And where that butts up, gesturing like this, where it butts up against the outside wall, even if you insulate all of the outside wall, there'll be some heat being conducted away by that partition. So we've put a thinner layer of insulation on some of the partitions where we thought that was a particular problem. So in some rooms, we've got a chimney breast and we've just insulated as far as the chimney breast. And then because the chimney itself is an outside space, we insulated around it, but we didn't then continue beyond that. We're in a terraced house, so we've got lots of internal party walls. And there is an advantage because if they go on holiday and the heating's off, then it can get cold in the neighbour's house. So it's not a waste of time doing that. And what I found from doing it in our house is that if you're disrupting a room and you need to rip bits off the wall and move all the furniture and everything, it's clearing the room and then redecorating afterwards is the bit that took the most time. You can see Amanda shaking her head. It is disruptive. I know it's disruptive to do all this, but it was doing that took the time. And those are very standard jobs that you could pay a painter and decorator to do. That's easy. Fitting the insulation was the bit where we did that ourselves. And once you're doing that, it doesn't take much time to put slabs of insulation on the wall. So in retrospect, there's a bit of me sort of thinks maybe I should have done all the walls, but we did just do the outside walls. Yeah.
Okay.
So not a silly question at all. Tony?
I just wondered when you were doing the insulation of your, well, certainly your external walls, presumably you had to ease all your electric cabling forward and put new back boxes on, did you? So
we were quite fortunate in our house in that there were very few points where we needed to move any sockets, just the wall, because we weren't doing every wall. And actually the radiators happened to already all be on internal walls. Otherwise we might have needed a plumber to help with some of that. But yeah, there were a few places where, yeah, we turn the power off, remove the socket and essentially leave it sealed away in a plastic bag until we'd finished the job and then screwed it back onto the new wall. So we did that. I'm trying to think. I think there were 4 sockets in the whole house that I had to do that with. If you're happy rewiring a plug, it's not much more difficult than that. But again, as I said on the safety slide, if you're not comfortable with it, get someone to help you. But it's not really difficult. And in terms of the cables, I said I'd explain this. So essentially the method is to get a thin plastic pipe and to put that round the electrical cable so it's got an air pocket around it, and then to insulate around the pipe rather than around the wire. So it doesn't need a lot of space, but just a bit to give it some space to dissipate some heat. And it's only going to get hot if you're drawing a lot of power through it. So the Hoover is the most likely in most rooms that will draw power, but only for a few minutes. If it's a cable for the oven, then you really do need to be a bit more careful, but yeah. Or the shower, I suppose. If you've got an electric shower, that would make a difference.
Yes, it's a good excuse if you want to move a few sockets anyway, isn't it?
Yes, yeah. It's actually, there's a bigger point there actually, that a lot of these things, there are good moments to do it, if you like. So we chose, when we did the kitchen, it's quite an awkward room to insulate, but we took the opportunity to replace the sink and the worktop. We kept the cupboards because they were fine, but combining it with another job when you're going to be making a big mess anyway, if you need to do the rewiring or you want some extra sockets, it's a good opportunity to do that. Great. I think it's the travel transport section, which is going to be Izzy.
So yeah, transport. Again, a couple of recycled slides here from Ewan's presentation in October. But this bar chart is just really useful, and it gives some figures really to some otherwise quite obvious points. But it shows the carbon dioxide emissions per person per kilometre for different forms of transport. So in terms of a car journey, the emissions per person are obviously a quarter of what there would be if there were 4 people in the car. The emissions per person are a quarter of what there would be if there was only 1 person in the car. In other words, it's more efficient to get 4 people from A to B in 1 car than in 4 cars. As I said, is an obvious point, but it just highlights the benefits of car sharing, for example. And public transport could be considered the ultimate car share, as Ewan said before. So you'll notice bus travel, funnily enough, comes out worse than you might think in that bar chart, which is because the average occupancy of buses nationally is quite low. But in my mind, that's not a reason not to use them, because the more they're used, the more the per person emissions will actually drop. And as we know, in Leeds, the buses tend to be quite busy anyway. But and the most carbon intensive form of transport is, as we know, flying, because planes require a lot of fuel. And unfortunately, also, the greenhouse gas emissions that are emitted at high altitude actually have a greater impact on climate change. So this graph shows that, and the light blue bar shows the extra effect of the high altitude CO2 emissions. And also we have to consider that this graph shows CO2 emissions per kilometre. But of course, when we're flying, we're usually covering many more kilometres. Most of us don't take short journeys by plane, unless you're Boris Johnson travelling from London to Cornwall for the G7, of course. Yeah, that means, oh, some animations there I've forgotten about. But that means that the emissions from flying tend to be a big part of the average person's carbon footprint. So the average UK resident apparently typically flies the equivalent of 1 return flight to Turkey per year, or 4 flights to Amsterdam, which isn't as much as you might think actually, but in just that amount of flying emits more carbon dioxide than all the rest of our transport put together, an average person's transport. So 15% flying, 10% land transport, and 2% public transport. I guess that's public transport on land probably, and or sea. So yeah, flying is a biggie really. And so we want to try, alternatives if we can. And Ewan mentioned this website before, Seat 61. This is a very helpful graph, but there's loads and loads of more stuff on that website about how to travel to different places in Europe, particularly by train, and the carbon that might be saved if we did that compared to flying. And we can also take holidays in the UK. But what else there is to say about transport? In some ways, you might think that's kind of all we need to know. And in some ways, this graph kind of says it all. But we were thinking about what people ask about, and people do often have a lot of questions about electric cars. So we just thought we'd spend a little bit of time talking about electric vehicles. So firstly, why might an electric vehicle be a greener option? So this graph shows the overall carbon dioxide emissions of driving a car per kilometre. So on the left, we've got the average or conventional car, i.e. petrol or diesel, 2 different types for comparison. And on the right is charts for an electric vehicle. I think this study was based on a Nissan Leaf, because that was one of the most common electric car up until recently. So the blue part of the bars on the left shows the carbon dioxide coming out of the exhaust pipe. And you'll see on the right, the electric vehicles, of course, there isn't a blue part of the graph because there isn't an exhaust pipe and there's no fumes to come out of it in use, carbon dioxide or other fumes. But of course, the electricity itself comes from somewhere, and generation of the electricity usually generates some greenhouse gas emissions. So that's the red part of the graph. On the EV side, this is the from the electricity production, and so you'll see that how green your EV is depends on which country you're in and how green their electricity supply is. So this is a 2015, this is based on 2015 data, so it is quite old. So as Ewan has pointed out before, the grid in the UK is now much greener, so that would actually, this chart, this bar for the UK should actually be lower now. I think, you think by about half? The orange. Yeah, the red bit, or Ewan says it's orange, should be about half probably now compared to 2015. And you will notice there is a red bit on the petrol or diesel car section as well. That accounts for the carbon emissions related to processing and transporting the petrol and the diesel. But as you can see, there's another factor to consider, which is the emissions generated by the manufacturer of the car, which is also very significant. So that's the purple bit. And also for the electric vehicles, the green bit, which is the carbon emissions from the manufacturer of the battery. So even though this is the carbon emissions divided up over the whole lifetime of the car, it's still a very significant part of the overall emissions per kilometre. And Mike Berners-Lee, author of How Bad Are Bananas, which we've cited before, actually gives an even higher estimate for the embodied carbon, so the carbon in the dioxide emissions for the manufacturer. He estimates that on average 40% of the carbon footprint of an average use of a car per mile actually comes from manufacture and maintenance of the car, which I thought was quite surprising. So the points he draws from this are: buy a small car because there's less carbon emissions in the manufacture of a small and simple car than a big fancy one. And also in use, you know, it's more efficient driving around a small car because effectively you're dragging less metal around with you all the time as you drive. Also, if you can, share a car or join a car club, and make your car last as long as possible, because then you're kind of getting more use out of that embodied carbon, I suppose. And he also mentions, slightly separate point, but he mentions driving efficiently. So, you know, not hitting the brake too hard, not accelerating too hard, not driving faster than you need to. He says that can save up to 20% of emissions per mile. So again, that can be quite significant. So just think of driving the opposite of a boy racer. So on the subject of should you sell your petrol or diesel car and buy an electric vehicle if you could afford to do so, Mike Berners-Lee's conclusion is actually due to the embodied carbon of buying a car. He says that no, you shouldn't. You should keep your petrol or diesel car running till it dies, and then buy an EV, electric vehicle, when that dies, unless you've got an absolutely massive gas guzzling car. And I say that to point out that there are different views on the topic, but in actual fact, we didn't follow Mike Berners-Lee's advice. Around 18 months ago, Ewan and I did sell our petrol car and bought a Renault Zoe electric car. Our reasoning for that was our old car wasn't going to go on the scrap heap. As it happens, we sold it to a lovely Slovenian couple who needed a car for work, and I doubt they would have afforded an electric vehicle, whereas we were lucky to be able to do so. Even if it had gone on the scrap heap, a lot of the materials were being recycled, and we considered that buying an electric vehicle is supporting a green technology and encouraging others that it's a viable thing to do. But you know, as I said, different people have different opinions. But just to sort of, I guess, share some things that we've learned, I suppose, on this journey. And I know we're not the only electric car owners probably on this call, but oh, the other thing was I meant to mention, we weren't just considering climate change either, we're also considering air pollution, which is another massive issue. Air pollution has massive health effects worldwide. And this is a shameless plug because my brother wrote this book, which is a very readable book, I would say, about air pollution. So just some information about electric vehicles. This is just a slide showing some prices of electric vehicles that can be bought new currently for less than £30,000, but that's still a lot of money. So here's some examples of second-hand ones. They've actually been around for a while, sort of over a decade. Electric vehicles are on the market, so there are actually quite a lot of second-hand options available. The link on the bottom here is to a YouTube video which talks about the prices of EVs. I don't know if you want to put that in the chat, Ewan. And these are some of the sort of lowest approximate prices for the models on the picture. Obviously, you can pay more for something newer and, you know, with a larger battery as well, potentially. On that point, the more modern cars tend to have bigger battery capacities because the cost of batteries is reducing, and therefore manufacturers are affording to put bigger batteries in newer cars. So this graph shows the battery capacity of new cars on the American market over the years, but the trend would be similar in Europe. And just to point out as well, obviously there can be a difference between the manufacturer's quoted range figures and the real world figures. We're not, you know, that could be the same with miles per gallon as well, as we know. There is a very helpful website, this EV database, which has the real world figures for pretty much all the types of electric cars. This is one example of there, which is a VW ID3, which is quite a new car. So this is showing you the real world ranges, and the manufacturer's range, 260 miles. So this also highlights one issue that maybe we weren't aware of probably initially either, which is that the range is actually lower in cold weather, which is to do with the chemistry of the battery. It's not as efficient in cold weather. In the cold weather and they use on EV database, that's based on -10 and running the heating. But it is noticeable, you know, with our car, even just in the winter, the range goes down. And the average published range of new EVs tends to be around 250 miles. People often ask about charging as well. We found there's only really 3 places you need a charger in our view: at home, on a long journey, on holiday, if you're holidaying in the UK with your car. Other places are a bonus. As this graphic shows, there's both different speeds of charging point, and also different cars use different types of connector. So it's a bit like when you go abroad, you know, in the continent, they don't use a standard 3-pin plug socket we use. It's the same thing with electric cars. They're not standardized. Unfortunately, even in the UK, they're not standardized. So there are different types of socket that different cars use. But these are, I think, pretty much all the ones in use in the UK. Ewan, yes. Aaron Ewan says one of them is quite rare now. Is that the Type 1? Yeah, Type 1's not used often, and there's adapters available for Type 1s anyway. So in terms of different speeds, at home, obviously, you only really need to charge slowly. So the standard home car charger is 7 kilowatts. So our car would take about 6 to 7 hours to charge at home from flat. A home charging point typically costs around £450 with a government grant. You can even charge on a standard 3-pin plug, as long as you've got the right cable or buy the right cable for it, which is quite handy if you're visiting family and they don't have a charging point. Our car would take about 25 hours to full charge from flat on a 3-pin plug. So that's charging at home. On a long journey, obviously you want to charge much quicker than that if you're charging en route. So you want a faster charge, so you need a faster charge point. So most rapid charge points are 43 or 50 kilowatts, but some even charge at up to 350 kilowatts. That's pretty rare. But as well as finding the right charge point, you have to have a car that can take that speed of charge. So our car can take 43 kilowatts maximum. A lot of cars, for example, the Leaf, charge at 50 kilowatts. And a few very new and expensive cars will take 150 kilowatts or more. In practice, we find that charging at the motorway services, we tend to charge at about 1% of the battery per minute, which if you do the maths, which Ewan does, of course, because he's an engineer, it's not actually 43 kilowatts that we tend to find doesn't charge quite as quickly as advertised. I'm not sure if other people find the same, but some models, it's worth being aware, some models of car don't take 43 kilowatts charge even. So you really can't rapid charge them. So I would be wary of buying a car that doesn't charge that quickly. If I wanted to do any long journeys, you'd be sat around for a very long time charging. So do be careful of that, especially if you buy a Renault Zoe, because some models of Zoe charge at 43 kilowatts and some don't. And the difference between the models is not necessarily well advertised or advertised at all. So you need to check the model number very carefully if you want one that rapid charges. So just a sort of worked example of how that works in practice. So Ewan mentioned we're actually at his parents' house at the moment in Scotland in the borders. Usually we'd take the train there, but just during lockdown, the 2 times we've managed to come, we have driven. So how that's worked is we charged for 45 minutes at Washington Services, just outside Newcastle. And we arrived quite comfortably, 60 miles of charge left. We actually got that charge free this time and last year because the mechanism to charge was broken. So we got a free charge. It would usually cost around £5 to £6. Ewan's parents also have an electric car. It's a newer model with a bigger battery, and they can drive to us without charging at all very comfortably. So that's a 64 kilowatt hour battery, and ours is a 40 kilowatt hour battery. This is another example. Our friends Phil and Ruth Thomas, who some of you might know, they took the opportunity when their car got written off to buy a second-hand Nissan Leaf. It's a little bit older than ours, and it's got a smaller battery, 30 kilowatt hours. Phil's parents live a very similar distance, but south in Hertfordshire. And how they get there is they charge twice on average, 40-minute and a 30-minute charge. Although Phil says if he's driving and he slipstreams lorries and he pushes the battery right to the end of the charge almost, he can manage with 1 charge. But I think that stresses Ruth out quite a lot. So I think 2 charges is better. It would stress me out as well. Just to mention, this website is really helpful, called ZapMap. It shows all the charge points in the country. I guess there might be some that aren't registered on there, but it's pretty comprehensive. The different colours are different speed chargers. So the pink is the fast ones, generally. The blue is the slower ones. And you can filter by different types of connection as well. So yeah, it's kind of essential. We find having that app for driving around long journeys. And it's just a free app on the website. So that's it. So yeah, just does anyone have any questions or comments? I'll probably get Ewan to answer the questions anyway, but yeah, Stuart.
Sorry to go first again. Just a comment, really. I was trying to encourage my son to go electric. He's just bought a new car. In fact, I said I would give him the extra money that it would cost, but it was totally impractical because he has no off-street parking.
Yeah.
And of course, he can't be sure that he can park in front of his house. So he hasn't really got a reliable way of charging at home. And that must be true for quite a lot of people.
Yeah.
So it's just something to be aware of, that he would have to go to a charging point somewhere near his home. And of course, that's not really very
it's not
Doesn't
very
work very
practical.
well.
Yeah, it's frustrating that. I mean, we don't have off-street parking either, but we can fairly reliably park on the street outside our house. So we just run a cable across the pavement, and we have a cable mat to make it safe and make sure no one can trip over the cable and sue us.
And that's legal, is it?
Well, is it legal? Ewan did contact the council, and there was the person at the council was kind of very helpful, but he kind of was like, well, I can't tell you you can do it, but at the same time, kind of, he sort of implied that they look the other way. So we just done it anyway. But yeah, Ewan can fully win then.
It was a few years ago, and I don't know his name, but in essence, I sent an email saying I would like to buy an electric car and I don't have off-street parking. What is the solution? Because clearly, as a council, you need to facilitate this. And at the time, so he, rather than email me back, he rang me, which I think is quite telling. He didn't want to say it in writing, but essentially he said, I've looked where you live. It's a cul-de-sac. You're near the end of the street. I think it will be all right. And he was quite explicit in what he was saying, that he thought it would be all right, but he didn't want to write it down. And there are charging points around the place. I mean, it's certainly not convenient, but I would say when we said there's 3 places you need to be able to charge: home, long journeys, and on holiday, it doesn't necessarily need to be at home. It could just be near home, but it needs to be somewhere that fits with your week. And it's, and yeah, we need to see more charging points in areas where people can't park on driveways. There are solutions being developed. There are products that are available now that councils can buy that sit on the pavement, and it's just a reserved space, in the same way there are reserved spaces at service stations and so on. I haven't really seen many in Leeds. In Leeds, there are some charging points at council leisure centres that the council's put in partnership with a company. There are some different retail parks. The university has got loads on their campus, and sometimes you can park there. But yeah, it's not as reliable or convenient as it needs to be. Yeah, a good reason to write to your council. Yeah.
It can also depend where you work as well. One of my friends bought an electric car purely because he got a free parking space at work, because he works for the council and he can charge his car. So he didn't need a home charging kit because he always charged it whenever he was at work.
That's great. Yeah, some employers are really sort of grabbing the nettle, if you like, on this. So yeah, there may be some employers who install chargers at work or so on. What I would say, word of warning there, that's fine until lockdown. And then if you're not going to work anymore, it might, that solution may fall apart, but I guess everyone's fully aware of that risk at the moment. So I did read a story about a couple who had bought an electric car on that basis and then got into trouble because they were stealing their landlord's electricity by trying to charge at home. Their landlord happened to be the Queen. They lived somewhere near Windsor Castle, but I'm not sure what the end of that story was, but hopefully because they got into the press, so maybe they were trying to get the solution they wanted rather than what was actually happening. The other thing that's maybe worth saying there is, in a normal week, if it depends on what you do and where you work and how far you drive, but a lot of people, if your car can do, let's say, 150, 200 miles, I don't drive that in a week, even a busy week, normally, unless I'm going to visit family. It's quite a long journey. Some people work tens of miles away, and they'd get through that mileage very quickly, and they need to be able to charge. So it's partly a lifestyle thing. Yeah. For us, we typically only charge the car about once a fortnight anyway, so we don't need to be able to park outside the house every day, although we normally can. More questions? Susie.
Oh, sorry. I wondered if you've got any advice or opinions about second-hand electric cars and just battery life.
Sorry, Izzy spoke to the last word of your question I missed, sorry.
Just about battery life of second-hand EVs.
Yes, absolutely. So yeah, so if you have, it's the same sort of battery as you have in a mobile phone, lithium-ion battery or a laptop, and we're all very aware that after, let's say, 3 years, the battery life, or even less, the battery life in a phone drops off quite quickly. That happens to some extent in an electric car, but I would say generally not to the same extent. And this is partly because manufacturers have got very aware of that risk and how to manage it. And essentially what they do is the battery that you get in the car is never fully used by the car. So there's a bit at the bottom and there's a bit at the top of the charge cycle that they don't use. And that makes it last a lot longer. And then there's a whole sort of computer control system managing the battery charge and discharge, which is all a slightly long-winded way of saying that car batteries are lasting a lot longer than most people thought they would a few years ago. And there is a lot of data out there for the older electric cars in how long they will last. So we mentioned our friends Phil and Ruth, who bought an older Leaf, and if you know anything about Phil, you know he likes spreadsheets. So he's got a lot of data that he collated from various websites and worked out, broadly speaking, the correlation between battery mileage and the range that you'd realistically expect to get from it. And it does drop off a bit, but it's not as much as you might expect. If you just think about a mobile phone or a laptop, it's not that bad. There are companies out there who are developing ways to recycle the batteries. And one of the problems they've got is there isn't the supply of the batteries to recycle for them to sort of test and upscale their process. So yeah, that's one of the other concerns people talk about, is what we're going to do with all these batteries. Christine, I saw you had a question.
Yeah, well, just a comment really. We've got 2 Leaves, and one of them was we bought second hand about 3 years ago, so it had already had 3 years of life. And there's absolutely nothing wrong with the battery so far.
Yeah, I suspect it depends a bit on the previous owner, but that you could say that about the clutch or any other aspect of a petrol car as well. You're never quite sure, but yeah, I mean, it's not answering your question, but there are newer cars out there where they're talking about batteries that they might guarantee. People talking about the idea of guaranteeing a battery for 1 million miles. Now, clearly, the rest of the car is going to have fallen apart long before it gets to that point. But it's getting to that point where it's being talked about seriously that it could last that long. I think there's something going on in the chat as well that Izzy's responding to. Yeah, if anyone does need to go, that's absolutely fine. So, but we did say we'd finish at 9, but equally I'm happy to take any more questions or join in a discussion. Janet.
Do you think a hybrid is like a good middle ground because they're slightly cheaper than a full electric or?
Yeah, I sort of anticipated someone would ask this, and I was trying to think through what I think about it. I think the first thing to understand is that there's quite a wide range of what hybrids are, if you see what I mean. So a lot of Toyota, a lot of hybrids out there are Toyotas, and they kind of pioneered it with the Prius car. I don't know how long ago that's now, 15 years maybe. And if you think about the range that they can do just on the battery, it might be 1 mile or 2 miles. It's often quite a short range, but they use that battery to, they're constantly charging and discharging it to make the car run more efficiently. So you get kind of more bang for your buck in terms of the battery and the benefit it's bringing you. At the other end of the scale, you've got things that are technically a hybrid, like there's a BMW i3, which is kind of the small hatchback BMW you might have seen around. And you can get pure electric models of that, but you can also get ones where you've got a range of, I can't remember, it's quite a high range, maybe 200 miles or so, but there is a small engine there to get you home in case of emergency, because when that car has been out for a long time, they weren't so sure about the infrastructure, and they put that in as an option, which a lot of people went for. So secondhand, a lot of them are technically hybrids, but not really.
Yeah.
My parents had, still have a Golf hybrid that can do, I think the official figure is 30 miles on the battery. In reality, they say it's more like 22. And that, if you think about, for a lot of people, 20, 30 miles, that would cover most of your journeys. So if you can plug it in reliably, you'd say, well, 90% of my journeys are all electric, and then I'll only use the petrol when I go to visit someone in a different part of the country. And that to me feels like a good option. But it depends a bit on your lifestyle as well. One thing I would say as an engineer is, whilst it's cheaper, you've kind of got two engines, and that's twice the sort of things to go wrong, but maybe you've got a backup if only one goes wrong. And in theory, there should be, I feel like instinctively they ought to cost more because you've got those two engines. It's just the batteries were expensive and the petrol technology was well established and therefore quite cheap in comparison. So yeah, I don't have a definitive answer, but I would say don't just say, oh, hybrid, definitely halfway between petrol and electric. It depends.
Yeah. My car's currently in the garage and needs a new engine, so I'm kind of been looking at cars at the minute.
Izzy's just reminded me, actually, there's also the difference between a plug-in hybrid and a non-plug-in hybrid. So a plug-in one allows you to charge the battery up off the mains, and a non-plug-in one is only charging it up when you brake, essentially, using that regenerative braking thing. Toyota have been criticised for quite a few reasons, but one reason particularly recently, an advertising campaign where they talked about self-charging hybrids, which sounds amazing until you think, oh, hang on, they've just left the plug out. Why would you leave the plug out? It's not an expensive element of the whole car. Just, so don't believe the hype either. That's a universal message for all marketing. Phil.
There seemed to be a lot of criticism about electric vehicles in that there would be piles of used batteries somewhere littering the earth and causing pollution somewhere in the Far East. But from what you're saying, do you think that batteries will just keep either keep going longer or will be able to be recycled more easily?
Yeah, I think a mixture of all those things. So the batteries are lasting longer than most people expected. There are companies out there developing the solution to recycle them. I guess it's still to be seen whether that becomes a mainstream solution for the batteries at the end of their life. The other thing that is happening to some degree is when a battery has reduced its capacity enough, too much to be of much use in a car, it then being removed and used for something else. So a static battery that's then connected to the grid or used in a house to manage supply and demand in that way. Because at that point you say, well, the capacity is reduced. Let's say it's gone down to 60% of its original. In a car, that's a problem because you can't put in two batteries. In a building, weight and space are much less of an issue. So you just say, well, I'll put in two of them and now I've got 120% capacity. And so there's different solutions there, but I don't think it's going to be the problem that a lot of naysayers are happy to say it will be. but I'm not saying there's no issue there at all. With anything that we manufacture, we need to think about the end of life, absolutely. And nothing will last forever. But Stuart.
Sorry.
No? You're just waving.
Is there anything else on the horizon beyond electric vehicles? We were chatting to somebody today at Fountains Abbey, and he said hydrogen is the future, fuel cells.
So there are hydrogen cars around. There's a couple of points there. I'd say the biggest barrier probably is we could all charge an electric car at home now, because you can charge them on a 3-pin plug. Now, I'm not saying it's a quick way to do it, but for a few £100s, you could then put in something that charges it faster and a much more viable speed. Where's the nearest hydrogen station? Does anyone know? I think there's one in Liverpool somewhere, or in the Mersey somewhere. They're not around. We haven't got that infrastructure. We've got billions of pounds of infrastructure around delivering electricity, and there's much less in the way of hydrogen infrastructure. We could build it, but it feels like quite a big barrier to the uptake. The other thing to consider is, where is the hydrogen coming from? So the cheapest way to make hydrogen is from natural gas. That gives off CO2. You can capture the CO2 in theory. You can't capture all of it, but then that's going to put the cost up. You can also make hydrogen from renewable electricity. You split water into oxygen and hydrogen, and that's entirely green, but that costs more, and neither of those things is being done at the scale that we'd need for everyone to switch to hydrogen. And I feel like if only some people switch to hydrogen, the economics of supplying it and the distribution network, if you like, it's going to be harder to get that up and running, and the business case for building all of that, if it's only 30% of cars, for example. Having said that, there's a more reasonable debate, I think, about heavy goods vehicles. So running a lorry off batteries can be done, and some companies definitely are pursuing that and think that's the solution. But there are a significant number of companies saying hydrogen makes more sense for that kind of heavy goods vehicles where you need the torque and the haulage capacity. But it's a much more realistic thing, in my mind at least, to supply hydrogen to specialist vehicles that are operating on very known regular routes, as opposed to everyone driving their cars everywhere. That's a much harder market to meet. But yeah, there are quite, what I've started to see in the last year or so really is some electric vans around as well. There's lots of delivery vans around, obviously, but I've seen 1 or 2 electric on our street, and I know there are other companies pursuing that. So that kind of medium weight definitely seems to be going electric. We'll have to see, but yeah, I don't think we're going to see a lot of hydrogen cars around. They cost a fortune as well at the moment, way more than batteries. And in some ways, it's whoever gets there first and gets to that tipping point on the curve I showed at the start of the presentation. If it gets to a point where electric vehicles are so far down that curve that the hydrogen technology just can't compete, it's going to be blocked out of the market, I think. That's my personal view. We'll see. I think the questions have slowed up. I think we can wrap up there, but happy to talk at any point if anyone wants to get in touch. Oh, David, one more.
Can I go back to heating your house?
Yeah.
If I'm realistic, I find I'm quite pessimistic about using heat pumps and the other one that goes into the ground. And insulating everybody's house. Can this realistically be done? Can we have everybody having decent heating in a house on these sort of systems? It doesn't sound to me, it sounds very difficult. Are there any other things that are being looked at?
So, yeah, it's a good question. So government policy really is looking at 3 ways to 3 ways to decarbonize heat, which is the point that I was making, that's a key deliverable. If we don't decarbonize heating, then we can't decarbonize the UK's economy. So I mentioned, obviously insulation helps whatever your solution is, so that's a key thing. I mentioned heat pumps. I briefly mentioned district heating, which is where the heat is generated at a central location and piped to lots of buildings through insulated pipes buried in the street. That's being built, or is already working, in the centre of Leeds, where our black bin waste goes to a waste incinerator, and the heat from that is then piped into the city centre, and it's serving multiple buildings, mostly initially council buildings, but I'm looking at possibility of could the church connect to that, and there are other buildings that are connecting to that network as well. And again, that's something that's widely done in Scandinavia and lots of other countries. And then the other solution, potentially, having talked about hydrogen, is can we decarbonize the gas grid? And partly for some of the reasons I just mentioned, I think that's going to be quite a big challenge. But there are a lot of organizations looking at whether we can decarbonize the gas grid by changing the gas from the methane natural gas that we currently use to hydrogen, or perhaps a mixture of hydrogen and biogas, which comes from rotting vegetation. I mentioned the challenges in creating that and the carbon emissions potentially with creating that hydrogen. It also feels like a massive change you'd have to change everyone's boilers, you'd have to change everyone's cookers, and you'd have to potentially do that all at the same time, because if the gas grid has changed, it's changed for everyone in that area at least. The companies that are pursuing it are the companies that operate the gas grid. They've got a huge vested interest in making this seem like a viable solution. So I'm not inclined personally to believe absolutely everything that they say, but they've got a big point in that there's, again, billions of pounds worth of infrastructure tied up in this gas network that delivers a fossil fuel. And if we can't switch it to a green fuel, then we're essentially saying it's now worthless. We can't afford to use it because of climate change, and we can't use it for anything zero carbon unless we use it to deliver a green gas. So I'm sure they're putting a lot of effort into making it a possibility, but realistically it will be at least 10 years before we see anything practical coming out of that, I think, in terms of real people's houses switching. There's demonstration projects going on, but it is quite a challenge. And yeah, if everyone switched to heat pumps tomorrow, the electricity grid couldn't take it either. We'd need to combine it with insulation to reduce the demand, and there needs to be an increase in the electricity infrastructure to deliver that power as well. It's definitely not an easy thing, but government keep trying to persuade people to insulate their houses in different ways. You'll have heard of the Green Deal, that for all the bad reasons, it didn't really work out. And then there was the Green Homes Grant, which I actually mentioned on the talk I gave in October, and then was scrapped by the government because it wasn't really working. But it's a really hard nut to crack, essentially, to persuade people to make a bit of a mess of their houses and then repair that, sort of redecorate. It's a very can be a very disruptive thing to do, but we need, and at the moment it's quite an expensive thing to do. But it's mostly the labour that's expensive. The materials aren't too expensive. So yeah, we need to solve this problem, and it's not an easy one.
Okay, thank you.
Okay. Yeah, just a couple of other things. I mentioned this relay at the start, just a reminder to look it up or to get in touch. This website's got all the information that you could possibly want, different ways to get involved, not just walking. It could be planning the route, which is something we've done and found very easy, or being a support for people walking, so being available to drop people off, pick them up, rescue anyone who's twisted their ankle or anything like that. They want some people to put people up for accommodation, but I don't think they need loads of people to do that. And then we're trying to organise an event in Leeds. Probably we're thinking on the Saturday morning to send off and commission the walkers who will be walking on that day from Leeds to Aberford. And we're imagining something like a walk of witness type thing around the town centre, perhaps between key locations, churches, Millennium Square and so on. We'd love to have some help organising that. It doesn't need to be very complicated, but more people to organise that and people to turn up to it as well. So yeah, please do get in touch if that's something you'd be interested in. All the recordings of all the previous sessions are available on the St George's website. If you go to resources and then Climate Justice, or there's a YouTube channel. On the YouTube channel for St George's, there's a playlist of all the videos. We're a little bit behind with what's on there, but it will all be there eventually. Certainly all the early ones are. And that's my email address if you'd like to get in touch.